In this video, I'm going to show you how to create a math project that can be used for AP Computer Science Principles. It can be used for a project in class. It could actually be used for your Create Task. It's going to cover all the requirements. It's going to have iteration, selection, sequencing. It's going to have functions and parameters, and it's also going to have a list. So this is a very good project. And it's a pretty easy project. So what we're going to do is we're going to go over Collatz conjecture and what that is. That's a mathematical conjecture. And what I'll do is I'll show you a good video on this, a short clip of a video to explain what Collatz conjecture is, and then we'll program it. So I'll be back in a second. Here's the video.
Here's how it works. Pick a number, any number. 7? Good choice. Okay, we're going to apply two rules. If the number is odd, we multiply by 3 and add 1. So 3 times 7 is 21, plus 1 is 22. If the number is even, we divide by 2. So 22 divided by 2 is 11. Now we keep applying these two rules. 11 is odd, so we multiply by 3, 33, and add 1, 34. Even, divide by 2, 17. Odd. Multiply by 3, 51, add 1, 52. Even, divide by 2, 26. Still even. Divide by 2, 13. Odd. So we multiply by 3, 39, add 1, and that's 40, which is even. So we divide by 2, 20, divide by 2, 10, divide by 2, 5. Odd. Multiply by 3, 15, add 1, 16, divide by 2, that's 8, and then 4, 2, and 1. Now 1 is odd, so we multiply by 3 and add 1, which equals 4. But 4 goes to 2 goes to 1, so we're in a loop, and the lowest number is 1. Now the conjecture is this. Every positive integer, if you apply these rules, will eventually end up in the 4-2-1 loop. This is commonly called the Collatz Conjecture after German mathematician Lothar Collatz, who may have come up with it in the 1930s. But the problem has many origin stories and many names. It's also known as the Ulam Conjecture, Kakutani's problem, Thwaites Conjecture, Haas's algorithm, the Syracuse problem, and simply 3n plus 1.
Why is 3x plus 1 so famous?
Among professional mathematicians, maybe it's not famous but infamous, in the sense that if someone actually admits in public that they're working on it, then there's something wrong with them.
The numbers you get by applying 3x plus 1 are called hailstone numbers, because they go up and down like hailstones in a thundercloud, but eventually they all fall down to 1, or at least we think they do.
All right, so let me show you the setup of this project. So we have an opening screen. I have it set as default screen 2 because I added this later when I was doing a practice run of this. So we have Collatz Conjecture. I have a picture of the mathematician. I have an input number, and then I have a text box. So after the program runs, when we go to display, I'm going to switch to screen 1. I'm going to print all my hailstone numbers, and then I'm going to print the number of hailstones that I have. Okay? All right, so let's start the coding on this. Okay, so the first thing is, let's set up some variables. Okay, so the first thing that I want is I'm going to need a list here to store the hailstones. So I'm going to have hailstones, and I'm going to have an empty list. Okay. I'm also going to need a count to keep track of how many hailstones I have. So I'm going to say count equals 0. Okay. Now, what are some of the other things I need? Well, I need a seed number. Okay, so I'm just going to set up a variable for the seed. So we'll have that. All right, so now to start getting our information into this program here, we're going to need that input number. Okay, so that input number is text input 1. So when that box is changed, so I'm going to use a event handler. Go say when I say on event, and I say text input 1, and it changes, what I want to do is I want to grab what's in the input box. So I'm going to say get number. Well, I'm going to first say seed equals, so I'm going to say seed equals, and then I'm going to get the number from that box. Okay, so we're going to move this into here, and we're going to say get number, and we want it from text input box 1. All right, so when that box is changed, somebody's putting a seed number in there, and we're going to get that number. Okay? All right, so that'll be the first part with setting up our variables. Okay, for the next part, what we're going to do is we're going to write our functions that are going to do the calculations for if the seed is even or odd. All right, so let's write our first function. It's going to take a parameter. All right, so we're going to say, we'll say first even seed. All right, and we'll call this n. We'll use n as the input for it. Okay, and we're gonna say if if n comes in and n is even, we know we want to divide that by 2. All right, so we're going to make this statement. We're going to say n equals n divided by 2, and then we're going to return that value back to the on event where we're going to call it from. So we're going to return n. Okay, and we do a similar for the odd seed, just with a different calculation. So we're going to say odd seed, and then this time we want to multiply the seed by 3 and add 1. So we're going to say n, oops, we want odd seed. We're going to say n, whoops, I don't know why it's doing that. N equals 3 times n plus 1. And then we want to return n. Okay, so we have our functions written on what we're going to do with this. So let's go back to the on event. And what we want to do is we want to start to write our code that's going to start generating these hailstones. All right, so we're going to start it with a while loop. So we're going to say while seed is greater than 1, so the loop is going to keep going while seed is greater than 1, and we're going to put an if statement in. All right, so we have iteration with the loop. We have selection with the if statement. We have a list here. Okay, so we're going to say if. Now, how do we check to see if the seed is even? So we want to use modulus. Okay, so now if you remember, modulus is the percent sign that checks to see if we have a remainder, or what the remainder is based on what we're dividing by. So when a number is even, when you divide by 2, or when you do modulus 2, the remainder is 0. So if we say seed modulus 2, let me go to text here, and we say equals 0, that means that this must be an even seed. So we're going to call the even seed function. So I need a call statement for even seed. So we're going to say even seed, and we're going to send it seed. Okay, now we also want to restore it in the seed so it keeps going through this loop. So what I'm also going to do is I'm going to say we're going to let seed equal even seed. So what it'll do is it'll call the function. When it returns, it'll store it back in seed again, so we can reuse it. Okay. Now we're also going to do the same thing for the else part of it. So if it's not even, it's odd. So we're going to say, again, seed equals, and then we're going to call odd seed. And we're going to send it. We're going to send it seed. Okay. All right, so that should get us going with the loop here. If seed is greater than 1. Now what we want to do is we don't have to keep track of the count yet. We can do that at the end when we're printing out the hailstones. But we do need to start storing these into our hailstone array up here, or list. So what we need to do is every time we call the function, we should store the n. Okay? So if we look at this here, so we have our first seed, so we should have a function append. So where's append at? Okay, so we want to append to the list. We want to append to hailstones, and we want to append what we sent to it. So we want to append n. Okay, and we want to do the same thing in the odd. Okay, so we have hailstones, and we want to append to it n. Okay, all right, so we have that set up. Okay, so let's do some watcher variables here. Let's do seed. Let's do hailstones, and let's do okay. Let's just start out with that. All right, so if we run this, okay, now I am going to have to, well, I can call the screen. I can switch over to screen 1 when we're ready. I just want to look at these variables here. So if I run this, seeds undefined, let's say I put in 8 and I hit enter, and now it says seed is 1. Okay, my hailstones is correct. It goes 842 now. I'm not seeing seed is 1 because it went through the whole loop, so this is working properly. Okay, if I reset this and run it, and I put in 20, there are 7 items in the list, 20 down to 10, down to 5, to 16, to 8, to 4, to 2. Okay, so that is working properly. Okay, perfect. Okay, so we have that working. Okay, in the last part of the video here, we're going to fix it so that 1 will be part of our hailstones. And in order to do that, what we have to do is we have to switch the while loop. So while the seed is greater than or equal to 1, it'll still process. Okay, but the problem is we'll get caught in an infinite loop if we continue to call our functions for even seed, odd seed. So what I'm going to do is I'm going to put in an if statement. Okay, so I'm going to put in an if statement that adds seed. It's going to add, if seed is equal to 1, what it's going to do, it's going to append it to my hailstones list so that I can get it added to the list. Okay, so it's going to add seed to the hailstones list, and then I'm simply going to break the loop so that I can exit out of the loop. So I'm going to put in break, and this should work for this. Okay, so let's take a look. Okay, we run it. I put in 8, and I get 8, 4, 2, 1, and I have 4 hailstones. Okay, run it again. If I go 20, I get 20, 10, 5, 16, 8, 4, 2, 1. Good. Got it working. Let's put in a bigger number. Let's put in 50,000. And if you look here, this keeps going and going and going. And we actually have 128 hailstones. Okay, so this conjecture says this is true for every positive integer. It'll always end up in the loop 4, 2, 1. All right, so I hope you like my program. This is something that, again, will cover everything you need on the AP Computer Science Principles Create task. Like I said, it's got a list. It's got functions with parameters, so I'm calling functions with parameters. It's got sequencing. It's got iteration loops. It's got if statements. And it's not that crazy amount of code in order to do this. All right, so I hope you please like and subscribe to my channel if you do like it. All right, thanks for watching.